Welcome to True Projects. In this video, we are going to explain about a project titled Extreme Learning Mission Applied to Software Development Effort Estimation. The project emphasizes the significance of precise effort estimation in software development projects, highlighting its potential to minimize the risk and enhance the overall project success. Within the software project management process, various activities are carried out using the specific methods to accomplish the project objective. During the software development phase, both quantitative and qualitative metrics are estimated to align with the customer requirements. The project's objective is to identify the factors that impact the effort estimation and compare the effectiveness of the extreme learning mission model with other estimating models in accurately predicting the effort. By incorporating the machine learning technique into the effort estimation process, there is a greater likelihood of achieving the accurate time estimate and project cost estimation, thereby increasing the chances of project success. The project explored the significance of precise effort estimation in software development project and its potential to mitigate the risk and enhance the project outcome. The software project management process involves employing the specific method to accomplish the project objective. During the software development phase, efforts are made to estimate the quantitative and qualitative metrics in order to fulfill the customer requirement. The project's primary objective is to identify the factors that impact effort estimation and compare the effectiveness of the extreme learning mission model with other established models to determine the most accurate technique for effort prediction. By incorporating the machine learning technique into effort estimation process, there is an increased likelihood of achieving accurate estimate for project timeliness and cost, thereby improving the chances of project success. These are the basic requirements that are needed to build this project. Hardware requirement: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is upload the software effort dataset. In this module, user can upload the software effort dataset to the application. It contains the features of attributes related to the software development project such as of code, complexity, team size, etc. And the second module is pre-process the dataset. This module focuses on preparing the dataset for training and testing. It involves handling the missing value in the dataset, which done by either removing the incomplete record or filling the missing values. The data is then normalized, which scale the feature to a common range. Additionally, the dataset is split into the training and testing part. Third module is Run KNN algorithm. In this module, the KNN algorithm classifies the test data by finding the most similar data point in the training set. The module uses 80% of dataset for training and 20% of dataset to predict the effect. And the fourth module is Run Logistic Regression Algorithm. This module employs the logistic regression algorithm for software effort prediction. It is a classification algorithm that predicts the probability of an instance belonging to a particular class, and the module is divided into the training and testing part, where 80% is used for training the data and 20% is used to apply the models for predict the software effort. And the fifth module is Run SVM algorithm. In this module, the SVM is a powerful algorithm that separates the data points into different classes by finding an optimal hyperplane. The module trains the SVM model by using the 80% of trained data and then applies the model to 20% of test data to predict the software effort. And the sixth module is Run MLP algorithm. This module involves using the multi-layer perceptron, which is a type of neural network that consists of multiple layers of interconnected neurons. This module trains an model using 80% of training data and then apply the model to 20% of the test data to predict the software effort. And the seventh module is Run ELM algorithm. ELM means of Extreme Learning Mission Algorithm is employed. Here, it is a type of neural network that randomly initializes the weight and bias of the hidden layer, making it computationally efficient. The module then trains an ELM model using 80% of trained data and then applies the model to the 20% of the test data. And the eighth module is comparison graph. And this module, it generates a comparison graph that illustrates the performance of all algorithms and use it for the software effort prediction. This graph displays the values of MSE, RMCE and AME. And the final module is predict the effort from the test data. In this module, user can upload the test data to the application for software effort prediction. The trained ALM model, which has been previously trained on the pre-processed training data, is then used to predict the software effort for the uploaded test data. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of test data and the dataset. And the main is a Python code file, and this is the run.bat file. Instead of executing the program in command line interface, we created a bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Software Effort Dataset button. By this, we are importing the dataset from this corresponding folder and click on this dataset and click on Open button. Here, we get an correlation graph where the x-axis represents the feature's correlation and the y-axis represents the feature name, and the box represents the feature important values, and all those features with the value 1 will be considered as of important features. And now close this graph. Here we can see the dataset is loaded and consisting of different columns and rows. Here of 8 rows and 13 columns within the dataset. And then click on Pre-processed Dataset button. Here, the dataset is pre-processed and normalized, and we can see the dataset size is of, these are all the data because that are pre-processed, and the dataset size is of 81, and the dataset is splitted into the training and testing part of 80% of data, that is 64, and the 20% of data is of 17 is used for testing the data. And then click on Run KNN Algorithm button. Here, by this, the KNN model is generated by using the pre-processed dataset. And here we get of error values. These are of MSE of 0.01, MAE of 0.09, RMSE of 0.10. And then click on Run Logistic Regression Algorithm button. By this, the logistic regression model is generated by using the pre-processed dataset with giving of MSP as 0.01, MAE of 0.07, RMSE of 0.1. And then click on Run SVM Algorithm button. Here, in the same way of logistic regression, it also gives of MSE, MAE and RMSE. And then click on MLP algorithm button. It also generated with the values of MSE, MAE and RMSE. And then click on Run Propose ALM Algorithm. Here, this ALM algorithm model is generated by using the pre-processed dataset with MSE of 0.002 and MAE of 0.03 and RMSE of 0.04. And then click on Comparison Graph button. Here, this is the graph where x-axis represents the algorithms we used and the y-axis represents of the value assigned for each algorithm, and these bars represents of the metric we used, like a blue bar represents MAE, orange bar represents MSE and the green bar represents RMSE. And then close this graph and click on Predict Effort from Test Data button. Here it redirected to the dataset folder and select any one of the test data and click on Open button. Here, the data present between the square bracket is of test record, and the after arrow symbol it is predicted as of 8505.86. In the same way for the all different test datas. In conclusion, that accurate and reliable effort estimation is crucial in software development project to reduce the risk and increase the chance of success. The use of machine learning techniques, specifically the extreme learning mission model, can improve the accuracy of effort estimation and reduce the time and cost spent during the execution phase of the project. The study identified important variables for effort estimation and compared the ELM model with other literature models, showing that ELM model present the best result for estimating the software design effort. The project suggests that the use of machine learning technique in the effort estimation process can increase the chances of success in the accuracy of time estimate and the project cost.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.